Okay, we're just going to go through question 11 now. I've actually come back to this question because I made such a mess of it the first time. On this question, we've got to sketch this graph y equals 1 over x on this small set of axes. Now, it's so small because it's just a sketch of the graph. It doesn't have to have any values on it, really, unless there are any significant ones. We just need the general shape. Now, if you can't remember what the shape of this graph looks like off the top of your head, you might want to use a table of values to help you. So if I just draw a bit of a table of values. Okay, so we'll have some x values and we'll find out what the y values would be that would go with those x values. Now, it has a negative section to the graph, so we want to make sure we've got some negative values in our table so that we can see what that bit of the graph looks like. I'm going to start at -3, and I'm just going to choose a range of values to substitute into this. I'm just going to keep going up, -2, -1. I'm actually going to put some fractional ones in as well. I'm going to go for -1/2, and just one more, -1/3. And then I'm actually going to use some positive values as well. So I'm going to use 1/3, 1/2, 1, 2, and 3, just like I did in the negative section. Now, I've not used 0, and I'll explain why in a second. But as we substitute these in, let's start with the positive ones because they're probably easier. Y equals 1 over x. That just means 1 divided by x. Now, 1 divided by 3, we could write as a decimal, but it's much easier to write as a fraction because it would give a recurring decimal. So just write that as 1/3. 1 divided by 2, 1/2. 1 divided by 1, well, we know that would be 1. Now, 1 divided by 1/2, how many halves go into 1? That's 2. And 1 divided by 1/3, how many thirds go into 1? 3. Okay, so this is actually giving us the reciprocal. If you remember, the reciprocal is 1 divided by that thing. We know the reciprocal of 1/3 is 3, and the reciprocal of 1/2 is 2, and so on. Now, 1 divided by -1/3, well, again, it's just 1 divided by 1/3, which would be 3, but one of those numbers is negative. So the answer is negative as well. 1 divided by -1/2 is -2. 1 divided by -1 is -1. 1 divided by -2 is -1/2. And 1 divided by -3 is -1/3. Okay, now if we just try and think about what sort of shape this would give us on the graph, starting over here, going across to 3 on the x-axis, and only up to 1/3, I'm just going to guess where that would be. Let's say it's there. Okay, go across to 2 and up to 1/2, something like that. Across to 1 and up to 1, so that's the same distance in the x and y direction. So about there maybe. Across 1/2 and up to 2. Okay, can you see it's making this curve shape? Across 1/3 and up to 3. Now actually, if we made that fraction smaller and smaller and smaller, imagine if that was 1/10. 1 divided by 1/10 would be 10. So it's already quite large, it's already up here on the graph. Imagine if it was 1/100th. 1 divided by 1/100th would be 100. So the smaller that fraction gets, the larger the answer to its reciprocal is. So, I mean, we could keep going all the way to infinity, and we would just keep getting a bigger and bigger number. So this graph actually tends off to infinity. It will never actually touch the y-axis or go through it. It will just keep going closer and closer to it. It sounds impossible to get closer and closer to something without actually touching it, but we imagine zooming in and zooming in and zooming in. Okay, and then the negative values do the same thing, but in a slightly different section of the graph. So -3, the y value is -1/3. -2 gives us -1/2. -1 is -1. -1/2 is -2. -1/3, -3, and so on. Okay, so we get the same shape but in a different quadrant of the graph. Now I'm just going to draw a line through these dots, if you'll let me, just to show the general shape, because that's all that's required of us in a sketch. Okay. Now it has some rotational symmetry, this shape, but it doesn't touch the axes like I said already. At this point here and at this point here, it doesn't touch the axes, and we call these asymptotes. These lines that it doesn't quite touch but it gets closer and closer to, we call asymptotes. I'll just write that down. You don't need to know that, but if you carry on with maths further in school, you will do.